All right, section 4.2 is angle measures of triangles. So first we're going to look at the triangle sum theorem that says the sum of the interior angles of a triangle is 180 degrees. Sum means addition, interior means inside. So if we add together the measure of angle A plus the measure of angle B plus the measure of angle C, when we add together all three angles, they're going to sum up to 180 degrees. So find the measure of angle C. So we know that the measure of angle A is 43 degrees, plus the measure of angle B is 85 degrees, plus the third angle, which is the measure of angle C, that's what we're trying to find, and all three angles added together equal 180 degrees. So let's combine our like terms. We have two constants here, 43 plus 85, so that's 128, plus the measure of angle C, which is what we're trying to find, equals 180. So now to get the measure of angle C by itself, we're going to subtract 128 from both sides, and we get the measure of angle C is 52 degrees. And you can always check your answer because you can add the three measures together and make sure that they do add up to 180 degrees. Here, the measure of angle A is 90 degrees because it's marked by that box, which means it's a right angle, which means that it's 90 degrees. So let's take the measure of angle A plus the measure of angle B, which is 60 degrees, plus the measure of angle C, which we don't know, that's what we're trying to find, and they all three add up to 180 degrees. So again, we're going to combine like terms. 90 plus 60 is 150, plus the measure of angle C equals 180. Subtract 150 from both sides so that we can get the measure of angle C by itself, and we get that the measure of angle C equals 30 degrees. And this is actually something called a special right triangle, which we'll get to later. But a 30, 60, 90 is a type of a special right triangle. So a corollary is a statement that can be proven easily from a theorem. It's pretty much a shortcut that you can use because of a theorem. So there is a corollary to the triangle sum theorem, and that's that the acute angles of a right triangle are complementary. This is spelled wrong. Complementary. So that means that if you have a right triangle, so we see this right angle at angle C, we know that the measure of angle B plus the measure of angle A have to add up to 90 degrees. So if this is 90, then A plus B have to add up to 90, because then that will total 180. So that's just a shortcut you can use. You don't have to use it. So we have triangle ABC, so I'll highlight that in blue, is a right triangle, which you can see by this right angle at angle B. So that's triangle ABC. And then we also have triangle ABD, which is also a right triangle, which you can see. Suppose that the measure of angle ABD is 35 degrees. So ABD is this angle measure right here. Suppose that's 35 degrees. Find the measure of angle DAB. So we want to know this measure here. So since it's a right triangle, since triangle ABD is a right triangle, the corollary tells me that these two acute angles, the 35 degrees and the unknown angle that we're trying to find, have to add up to 90. That's what the corollary or the shortcut tells me. So we're going to subtract 35, and that gives me an angle measure of 55 degrees for angle DAB. So we know that this angle is 55 degrees. If you want to check, do 90 plus 35 plus 55 and make sure that you get 180 degrees. So now that we found that to be 55 degrees, let's find the measure of angle BCD. D is right here. So we want to find this angle measure. So now we're just going to focus on triangle ABC, which is a right triangle. We have a 90-degree angle here, so that means the two acute angles, angle A and angle C, are going to add up to 90. And that's what my corollary tells me. So we're going to do 90 minus 55 to get me 35 degrees for the measure of angle BCD. If you want to check, just make sure 90 plus 55 plus 35 adds up to 180 degrees. So to find the missing angle measures here, we know that the three angles add up to 180. So we can do 180 minus 65 minus 50. I'll just write out the equation. So if we add these together, we get 115. So then 180 minus 115 is 65 degrees. Here, 45 plus 60 plus the measure of angle B equals 180. So that's 105. So 180 minus 105 is 75 degrees for the measure of angle B. And the last one is a little trickier. If we just focus on triangle ADE, it's a right triangle, which means that these two acute angles have to add up to 90, which means that the measure of angle A has to be 40. And now if we focus on the bigger triangle ACB, again, it's a right triangle, which means the two acute angles have to add up to 90. So if this acute angle is 40, then this one has to be 50. So they asked me to find the measure of angle C, which is 50 degrees. When the sides of a triangle are extended, other angles are formed. The three original angles are the interior angles. Interior means inside. So interior angles are on the inside. So that's these three angles here. And so far, we've only dealt with interior angles. But we can also look at exterior angles. So the angles that are adjacent to the interior angles are the exterior angles. Adjacent means that they share a common vertex and a common side. So you can see these two angles are adjacent because they share that common vertex and that common side. They're right next to each other. So this is an interior angle and this one is the exterior angle. Same thing, common vertex, common side, so interior, exterior, common vertex, common side, interior, exterior. So we're going to use some previous knowledge here to help us find the measure of angle 1. You can see here that this is a line. So we know that the measure of angle 1 and the measure of this angle here are going to add up to 180 since they make a straight line. We can use what we learned today to find this missing angle measure because we know that the three interior angles of a triangle add up to 180. So we know that 72 plus 58 plus, I'll call this x, add up to 180. So that's 130 plus x equals 180. Let's subtract 130 from both sides. And we get that x equals 50 degrees. So this angle measure here is 50 degrees. So to find the measure of angle 1, we can take 180 minus 50, since they're a linear pair, and that leaves me with 130 degrees for the measure of angle 1. Now that was a lot of work, and you can do it that way every time, but where else did you see 130 degrees in this problem? Right here. When you add together these two angles, we got 130, and that is not a coincidence. So there's actually a theorem called the exterior angle theorem that says the measure of an exterior angle of a triangle is the sum of the measures of the two non-adjacent interior angles. So first we had found this missing angle measure, and then we did 180 minus that measure to get the measure of angle 1. But we don't actually have to do that because like we saw, if you add together the measure of angle A plus the measure of angle B, you actually get the measure of this exterior angle. So if we go back to that problem that we just did, right? If we add together 58 plus 72, which we saw here, we got the measure of our exterior angle, which was 130 degrees. So this is the adjacent angle to the exterior angle because it shares that common vertex and common side. So we want to add together the two non-adjacent angles. So for example, right, this is the adjacent angle to angle 2 because it shares that common vertex and that common side. So we want to add together the two non-adjacent angles. So 60 plus 60 means that the measure of angle 2 is 120 degrees. So it's a lot less work. Here's the adjacent angle to angle 3, our exterior angle, because they share a common vertex and a common side. So we're going to add together these two non-adjacent interior angles. So 125 plus 30 is 155 degrees for the measure of angle 3. And same thing, here's the common vertex, common side. So this is the adjacent angle to angle 4, but we want to add together the two non-adjacent angles. So that is 113 degrees for the measure of angle 4.